Yes, it's all very well. I must say, I remember applying for a job at some university south of the River Thames. It was a job I didn't get. And before I put my application in, I showed my CV to my then professor, McClure Brown, who was a very distinguished and rather frightening elderly gentleman, and he looked through my CV over his half-moon glasses like this for a long time in his office. And sort of grunted occasionally. And after about 15 minutes of this terrifying ordeal, he looked up at me and said, "Well, Winston," he said, "when I read my CV, I don't recognise myself either." That's a bit how I feel at the moment, really. What I really want to do is to try and find a laser pointer, which I have somewhere in my bag, because the first thing about science communication is that nobody really pays any attention to your slides unless you indicate what they're supposed to be looking at. I can't find it. It doesn't matter, so you'll just have to bear with me. It's not very important anyway. This is a headline in the Daily Express, and I suppose it sort of triggered almost more than anything else the kind of scandal over the measles mumps vaccine kind of stimulated much of my thinking about how we tackle public engagement. It's really interesting to consider how the Daily Express and the Daily Mail in particular led a vigorous and quite unethical campaign persuading people effectively not to get their children vaccinated. And we as scientists completely miscued, in my view. It's all very easy to blame the journalists or Andrew Wakefield, the rather dishonest scientist doctor who's now finally his things are coming to roost. But essentially, there was a key issue which I think wasn't understood by government, by scientists, by doctors, by anybody who was promulgating the need for the vaccine. Interesting to consider that what was actually happening in places like Liverpool and East London was that vaccination with the measles vaccine fell to around 75%. And of course, at that kind of level, you end up with epidemics, and indeed, there have been a large number of babies who've developed measles, some of whom undoubtedly will be brain damaged, far more significant than the perceived threat of autism, which was threatened by Wakefield, a very serious misunderstanding of society, in my view, rather than of the scientists. And I think it's interesting to consider what was not thought about. And the key issue, I think, was the failure to understand the ethical responsibility of the woman holding the baby. And that's quite clear. To her, her ethical responsibility is the safety of her child. And if that means that her child should not have a vaccination which might threaten its life as she perceives it, then she's absolutely right to refuse the vaccination. And ideally, of course, the ideal solution for her is to have herd immunity, everybody else being vaccinated, so there's no risk of her child getting the measles anyway. And I think there have been oh, thank you very much, that's very kind of you. So I think there have been a number of, do you think I can work it out? Oh, I can. Yeah. So I think there have been a number of issues like that with a whole series of debacles about science in the last 10 or 15 years, which have sort of triggered my view, or really helped me formulate my view as a scientist about how we deal with some of these issues. And it's all very well to to blame my friend Melanie Phillips, who wrote some utterly ridiculous things. I mean, this is a woman who got a first at Cambridge. She's quite a brilliant individual, writing total nonsense, really, about Andrew Wakefield. And I say she's my friend because she is, but she's not prepared to listen to any scientific arguments, because there's a kind of view by certain people in the press that it's their responsibility, that if there is doubt, it should be promulgated. I think, sadly, Melanie will be responsible, in consequence, for a number of completely unforeseen things which will not come to the surface for another 10, 15 or 20 years. For example, it's very interesting to consider that one of the completely unexpected issues regarding to the failure to take up the triple vaccine will be that there will be tens of thousands of boys in Britain in about 20 years' time who are infertile because, of course, they develop mumps. And those sorts of things are something that we don't always perceive at the time of the science. There's Andrew Wakefield. Well, so what? This is what Melanie writes, he's been mocked, denounced, driven from his job. Medical and political establishment, of course, is the enemy. People like myself are the enemy, really, of Andrew Wakefield. Not at all, really. But fraud is fraud, and it should be perceived as such. But that's not really what I want to address today. What I really want to do is to go back to the theme of where I think we might start with public engagement more effectively. And to do that, I want to take you back to this object, which is in the British Museum, which was dug up in the Olduvai Gorge. It's a flintstone, which of course is doubly famous now because the curator of the British Museum recently has been on the radio, as you may remember, with his 100 most famous objects, this series that's been going on the radio, a brilliant series, and this was one of the first object he chose. Notice that it's been dated to be 1.5 million years old. BP, by the way, those of you that are not petroleum engineers, BP, of course, is before present. So it's 1.5 years ago, 1.5 million years ago, before present. Interestingly, BP does not actually refer to 2010. It refers to about 1950. And the reason for that is because in 1950, we changed our environment by exploding so many hydrogen bombs and nuclear devices in testing that we contaminated the environment so that carbon dating and things which depend on isotope dating are no longer accurate. Of course, carbon dating is not so important for something this old and doesn't have any biological material, but of course, around it will be surrounded by biological material. But the half-life of carbon-14 is about 5.7 thousand years. And so much of modern archaeology depends on those sorts of investigations, which are less accurate because of what we have done with our technology. So the issue really is, what is curious about this hand axe? Well, to me, the most curious thing is that there's another object in the British Museum which is hardly ever spoken about, which is the same size, the same shape, the same working, but is over 1 million years later in hominin development. It's 200,000 years BP. And in the space of 1 million years, ladies and gentlemen, human technology has not changed at all. That's extraordinary, isn't it? Given that the genes which make my brain are not so different from the genes that made the brain that made that tool. And that is a really interesting puzzle. What happened? Well, in my view, the thing that possibly really separates us from every other species is in fact stone. Because, of course, what we have here is something which resulted in pre-humans manipulating their own evolution. As a result, we ceased to have a vegetarian diet. We started to scavenge and subsequently hunt for meat. So we built a brain which contains a large amount of fats and gave us the food supply to expand that brain. And at the same time, of course, hunting and those sorts of collective activities added to the kind of communication that there is between individuals, which is partly responsible for where we are today as a unique species. And the interesting thing, of course, is that in the space of really quite a short time in development, this is Australopithecus afarensis, Homo erectus. The difference here is about 1 million years. and the doubling of the brain size from 450 milliliters to 950 milliliters is clearly quite an extraordinary evolutionary jump. Modesty forbids me to mention there's another skull on the photograph. But of course the modern hominid, us, has a brain of about 1450 milliliters, so it's a trebling of size over that period of time. Actually, it's not strictly true, because it's 1450 milliliters for men. On average, it's about 70 milliliters less for women. And in case you men are wondering why that is, it's simply because males are not prepared to ask questions to where they're going. There's absolutely no evidence of difference in intelligence implied in that difference in brain size. Indeed, of course, as you will know, Neanderthals probably had a bigger brain than modern humans in terms of pure volume, probably as much as 1,500 mils or maybe even a little bit more. What I've done on this slide is to draw an imaginary timeline and say that this represents, roughly speaking, 100,000 years. And if we draw another timeline, say, which can hardly be seen, which is that tiny dot there, that represents a fraction of that time. And in that fraction of time, we've built telescopes in 1608, 1609, Galileo's telescope, the spinning jenny, steam engine, Trevithick, of course, driving his engine through these Cornish lanes before collapsing into a ditch and retiring to the pub, and then having a meal of goose, and then finding out when they got back to look at the steam engine, it had burnt itself to a cinder. We've landed on the moon, and we've, of course, now got synthetic biology, whereby it's probable in the next year or so somebody, maybe Craig Venter, if not somebody else, will have announced that they've made a life form in the laboratory. So in 400 years, something quite staggering has happened. The genes in the brain haven't actually changed. The expansion of the brain hasn't changed notably clearly from certainly 40, 50, 60,000 years. Homo sapiens is the same species. There are some minor genetic differences, but they are pretty minor. But the expansion of the human mind is something which is truly awe-inspiring. And it's easy to remember that, let's take 1599, just before the telescope, when Shakespeare wrote Hamlet, he could have leant over London Bridge and spat into the water and said, well, it's not going to change in my lifetime. This is the view of London. And the extraordinary thing, of course, is, well, actually, admittedly, the Globe Theatre built by the Burbages did burn down 16 years later. But essentially, the view didn't change and wouldn't have changed. But now, of course, when we look at that view, we can't say where we will be in 5 years' time. So there's a promise about our technology, but there's a threat. The promise, of course, is that we live longer lives, I think more fulfilled lives, probably happier lives. We have extraordinary complexity around us, which is enriching our experience in a way that could never have been predicted. In my view, science, the fruits of science, are not predictable. But of course, as we have gone on in the last 400 years, our technology has also become increasingly threatening. And you could argue that ever since the hand axe, it's been a downhill path at one level. Hence, bad ideas, ? And I think that is really interesting, because it poses a major problem now when we look at the public perception of what we do. And if you look at the UK perspective of technology and the issues of the last 12 years, we've pretty well failed in almost every respect in terms of public acceptance of the technology. So we still have a House of Lords report on nuclear waste disposal, which was published 12 years ago, upon which the government has not yet acted. So nuclear waste is really in a much more dangerous state than it needs to be. We also have the paralysis of our nuclear power program, which is not developed. Indeed, there's every reason to suppose that if you stopped using a 1960s technology, but started using synchrotron technology and other ways of perhaps getting neutrons into the pile, whatever it might be, that you'd have a much safer method of generating fission power with less nuclear waste. But we are paralyzed in that respect. Indeed, in Britain, there's only one university out of 150 that still actually has a nuclear power station on its campus. That's Imperial College. And that's one that we will probably try and close. If we could close it, we would. But the decommissioning of a fission power station is not a simple matter, even as a research proposal. We don't yet have anything like adequate consensus on global warming. It's very clear that in spite of all the issues that we have generally arrived at by scientific consensus, we can't even get the most basic public assent in a place like Copenhagen last year. We spent £3 billion on BSE and CJD needlessly in the wrong sort of way. Foot and mouth disease was equally costly and unnecessary had we looked at other methods of dealing with it, such as vaccinology. GM crops is one of the most famous debacles in time. And really, I think if you went through all these issues, I mean, the one that, of course, attracts me mostly as an animal experimental license holder is the fact that people like myself are regarded by a very small part of our community as criminals. Yet, of course, 90% of the audiences I would speak to in a public place would be wearing leather shoes. It's astonishing how much that still holds sway with Home Office regulations, which are undoubtedly seriously inhibitory to good, ethical, responsible, humane science. And I think only with embryonic stem cells, actually, have we had anything like a victory. And I think it's interesting to consider what happened here. And I think the thing that perhaps separates them is the fact that here was a clear evidence of a technology which was useful. And maybe that's a lesson for us as scientists. But all these technologies, even going back to farming, have been threatening. The evidence for farming, for example, 11,000 years ago, is that once we started settling, we were much more subject to conflict. We know that in most farming communities in the Middle East, longevity was shortened, disease was increased. That was made worse with the hygiene in cities. If you read accounts even of the City of London as recently as 1800, it's a horrifying cesspit, really, for most people living there. And every single technology that one can consider has got a downside, which is hardly ever recognized at the time of the announcement of the invention. Here's a picture from Fair Mollison's work at the Natural History Museum showing the diseases, some of the bone diseases and joint diseases spread as a result in grinding corn in Abu Huraira. Here you see the severe number of dental abscesses caused by eating carbohydrates mixed with grit, for example, for the first time, for which mankind was unsuited, and the shoulder injuries caused by pushing quernstones to grind corn incessantly, work that was mostly, of course, done by women. And farming undoubtedly has been a technology which has a downside which we don't always recognize.
Hey y'all, I'm Paula Dean. You know, legend has it that Queen Victoria had such a love for that Smithfield ham. She had a half a dozen delivered to her court every week. That was back in the 1800s. Today, there are more ways to enjoy hams from Smithfield than ever. Even one that fits nicely on a slice of bread. Proof that you don't have to be a royal to eat like one.
Yes, well, Smithfield hams are an interesting case in point. The dangers are still present in modern farming. And it's probable that Smithfield's farms in Veracruz, Mexico, were the epicenter for the recent pig flu epidemic, where, of course, vast numbers of pigs lay dying scattered around their farms, where the hygiene was appalling. We don't know that for certain, but it's probable that those viruses may have developed from that environment. And certainly there are all sorts of examples in our farming industry which should cause pause for consideration. The extraordinary use of antibiotics, not merely as a growth medium, but to control infections, which of course have been one of the reasons why we've been so prone to antibiotic-resistant infections as humans, a downside that would never have been predicted at the time of antibiotic usage. And of course, it is true too that our technology has modified another massively important food industry. Something like 8% of the world's protein is due to fish ingestion. There are some 90 species, according to this paper in Nature, which are close to extinction in most seas. Hutchins' paper is now, of course, a classic, but it's still a very serious landmark. And notice that what he's mapped out, and these figures are still probably correct, that so many of these species have not recovered after ceasing fishing years later, and there's been some recovery in others, but only a handful of species have made full recovery after ceasing fishing for 10 years or more. And that is, I think, highly significant. So what do we do, of course? We turn to fish farming, not actually a new technology. I've put the Hebrew up on this slide just to demonstrate actually that it's very clear that Isaiah, looking at the construct here, is talking here about fish farming. This is not simply fishing from the Nile out of chance. It's actually using waters where fish have been deliberately penned in. There's a lovely woodcut of Peter Bruegel the Elder's taking over a picture from Hieronymus Bosch. And it makes a wonderful point which is relevant to us now. The fish that we most prize, for example, salmon, trout, tuna amongst them, eat something like 5 times their body weight in other fish. And of course, we are feeding them with fish products in an attempt to farm them. Here is the father, Eke, demonstrating to his son. But it's, of course, also a funny print. Here's a clam trying to eat, presumably, a trout. It's rather a nice little drawing, that, really, I think. And fish farming at the moment, of course, is not going to be the answer to our use of technology so vigorously to deplete the world's seas. It is a major problem. Why? Well, when you look to see how we farm fish, it might be surprising for you to know that in the average trout farm, something like there are 27 trout per average bathwater volume. It's inevitable they brush against each other, they panic together, they lose their scales, infection, trauma happens. There are lost water resources in parts of the world like Thailand. Certainly there's been a massive problem with pollution. Antibiotic resistance is common because, of course, quite often this is used in pond farming, and even in open sea where surrounded by nets, there is a different kind of danger. That is the danger to wild fish where lice can escape from the captive fish across the netting. And there's also, of course, concern that with global warming, there's environmental change going on, and it's been predicted that there may be such calcium loss in future from acidification of the oceans, even by minor changes of pH, that shellfish will in fact lose their shells, leaving aside, of course, the issue of the cruelty to fish, which is a growing issue for some people, of fish being caught in an inappropriate way as a result of farming. Just to come back to the farming on land issue again, this is rather a famous picture, of course, of Joseph Stalin up here, and he's listening to Lysenko. You may remember, and I describe it in the book, how Lysenko usurped one of the leading geneticists of his time, Vavilov. Vavilov was a remarkable young man. He went to Cambridge in 1915, 1916, studied with William Bateson, and became increasingly aware of the importance of Mendelian genetics. In fact, Bateson was probably the man who coined the word genetics, went back to the Soviet Union in 1916 after 2 years in Cambridge, with the aspiration to try and change Soviet agriculture, recognizing that so many people were dying of starvation because of food shortages around the time, just before the revolution and during the time of war. It took him a long time to get established, but by the mid-20s, he was very much a leading botanist. He collected 250,000 different species of seed from worldwide travels in South America, in North America, in Mongolia, China, in parts of Asia. He was an extraordinary, intrepid man. But his misfortune was that he was a member of the intelligentsia. And Joseph Stalin was threatened by the intelligentsia, and also the idea of Mendelian genetics was not something which was particularly appealing to the Soviet Union by the 1930s. And here came this peasant farmer who'd never been to university, which of course was a brownie point in itself, who had this notion that simply vernalization, freezing seed, was all you needed to do to improve its fertility in the ground. And the net result, of course, was that Stalin, with Lysenko, initiated this vast planting program, which resulted in massive crop failure around the Soviet Union. In Kazakhstan, about 1 million people died. In Ukraine, probably 4 or 5 million people died. And different parts of the Soviet Union were absolutely devastated by the lack of food in the mid-30s. What is interesting about Lysenko also, of course, is that he refused to look down a microscope. When Vavilov wanted to show him chromosomes, he said, those are artifacts. You're just using this as a matter of belief. And the sad thing about Vavilov is that he eventually dies in prison of starvation, a man who had given up his entire life with genetics to try and improve the lot of people to prevent starvation. So this misuse of genetics by Lysenko is extraordinary. There's a double irony about this because, of course, we now know, and I'll come back to this later in a few minutes, that, of course, simple Mendelian inheritance is not the only way that you can change subsequent generations. But Lysenko certainly did not really understand the limitations of Lamarckism at all. By the mid-30s, we have rising in Germany another use of genetics. Again, a very good example of how governments can use science for their own ends. Might be quite curious to consider this, but this gentleman here might be regarded as being quite altruistic. He's a doctor. He believed he was going to improve his society. His name is Dr. Mengele. Incidentally, that's Kramer, who was the head of the Auschwitz camp. And the interesting question here is that, perhaps by no means all of them, but some of these German scientists and doctors had what might be seen as an altruistic view that they were going to improve things, they're going to improve their society. What, of course, people like Mengele forgot was that their responsibility was to the people in front of them, not to the society. In my view, that was a mistake that was made. And these twins, of course, become, in Auschwitz, these sets of twins. It's a difficult photograph to look at. And you might think that that was such a powerful lesson for the human race that it wouldn't be ever repeated. And yet, actually, it has been in democracies, not just in totalitarian states. My point is that all governments are capable of misusing science, including our own government. Here's a photograph from the Carnegie Institute, which I date, I'm not certain of the date, but I imagine it's about 1952, because if you count the number of chromosomes here, there are 24 pairs, not 23, which is what was thought at that time. And what you see, of course, is that there's a clear, obvious evidence in this karyotype of a white person that a white person is completely different genetically from a black person, thus supporting the view that blacks should be treated differently. Miscegenation, of course, was a criminal offense in 33 states in the United States. In Virginia, the law preventing blacks and whites having sex together wasn't repealed until the mid-1960s, 1967, I think it was. So here's an example of a democratic, civilized society still misusing science. And of course, it happened on this side of the Atlantic as well. In spite of the Nazi Holocaust, more people in Sweden were sterilized without consent after the Second World War because it was thought they were unfit to bear children than actually before it. In the state of California, some 30 or 40,000 women were sterilized without consent because they were seen to be in some way mentally defective. And this happened in Britain as well, not in such large numbers, but it certainly happened in the 60s, where sterilization went on because it was the normal thing to do. Surgeons would slip when they did a cesarean section so that the fallopian tubes got damaged. I saw this happening with my own eyes as a young doctor in training. One of the reasons why I stopped doing medicine in 1969 was because I didn't want to be part of that authoritarian attitude as a very young house doctor. Because, of course, in those days, we were arrogant enough to believe that we could impose what we thought was our best scientific judgment. And that is a risk that we still have in all societies. And that's why I think we need to have a new compact. Let's just look at one of my own experiments, and forgive me for promoting my own work. I'm not meaning to promote it in any kind of way at all. But this is the biopsy of a human embryo. It's a time-lapse photography taken in about 1989, where we're going to take a blastomere away for analysis for a gene defect, in this case adrenoleukodystrophy, to establish whether or not the baby might have that gene, and therefore, if it's got that mutation, not to transfer the embryo to the uterus. If you like, a form of eugenics. And here you see, no you don't, oh you do, okay, it's time-lapse, so the embryo is moving around. So what's happening here, of course, is that we're going to make a little hole in the zona pellucida with a drop of acidified tyrosine solution, and then, of course, the tips of these pipettes can't be seen with the naked eye because the whole embryo is only, 100 microns across. And then you'll see the acid going in. A blastomere is taken away. I have to say that before doing this in humans, Alan Handyside and I did this in about 7 or 8 different mammalian models to make certain there was no risk to the fetus. But it doesn't destroy in any way the fertility of the embryo because each one of these cells is totipotent. Each one is capable of being a stem cell, effectively. So that was known a long time ago, and we used that knowledge in the 1980s to do this experiment, and there is an example of the embryo after biopsy. It looks pretty horrid, but actually what we found was it didn't affect fertility rates at all, and we started to get babies like this. These are the first twins born, and this is Lisa and Harriet, and the press called them perfect babies because we had avoided a gene defect which had killed an elder child in that family before the procedure. Notice that Harriet's got this lesion on her chin, which is not because a cell was taken away, it's because she fell over about 8 hours before the photograph was taken. Anyhow, the point of this is not to be congratulatory about this piece of technology, which at the time was seen to be really imposing and important. I don't actually think it is that important. I think that pre-implantation genetic diagnosis is probably overused and really very limited. But what is interesting is the response in the journal Science by Harvey Lodish, one of the world's leading molecular biologists, in certainly one of the world's leading journals to our work. He says, it's now possible to remove one cell from an embryo, characterize the DNA, and genetic screening of embryos may soon become commonplace, he says. And of course, once we've got the genome much more clearly mapped, he says, we'll be able to make, at the time of the biopsy, a color movie of what the embryo will look like when it grows up into an adult. And we'll be able, once we've got the DNA traits completely adequately understood, we'll be able to make be able to cover genes important for traits such as speech and musical ability. And so the mother will be able to hear her embryo speak and sing 3 days after conception. But, that's the problem that we face, that we think that we're far cleverer than we really are. And we actually don't predict where these technologies are leading us. It's my view that virtually every single piece of technology now that is published by scientists in newspapers tends to be hugely over-exaggerated in importance at the time of publication. The real value of that science is often missed and not fully understood for a long time afterwards. I'll give you a few examples in a minute. And the downside is almost invariably forgotten. And to come back to this notion of Lamarckism, of course, it's now pretty well established that one of the course of the issues that was never understood before is the issue of epigenetics. Here's a lovely piece of work by Françoise Champagne at McGill University, where she's taken mice who are low grooming, switched mothers around in litters, and it turns out that the low grooming mice have changes in the methylation pattern. No change in the DNA, there's no mutation here, but the consequence of this is a heritable change in behavior. These mice in subsequent generations don't merely also low groom their children, but they have poorer intelligence. Their ability to problem solve is diminished. And in this case, they've looked at estrogen expression in this particular nucleus in the brain, but it's not the only gene which is affected in this sort of way. Michael Meany, incidentally, from McGill University, has shown over some years some clear, rather similar effects in humans. And one of the interesting pieces of work he did some time ago, slightly differently, but about babies in utero, was as a result of the ice storm in eastern Ontario. You may remember that in 1988 there was a massive ice storm which knocked out some thousands of electric pylons and about 30,000 electric cables around the countryside. There was a massive power cut. Something like 600,000 people left their homes in Ontario during the depth of the winter. People died of exposure and hypothermia. And what Michael Meany did was to go back and look at women who were pregnant from the age from 18 weeks to 24 weeks pregnancy, and he showed that babies at that stage of gestation were clearly affected, or there was an associated effect with their cognitive performance after birth, which has remained. The interesting thing is whether that may be transgenerational. So we don't know the full impact of these epigenetic effects yet, but there is evidence here that this is a cortisol-mediated phenomenon which is clearly becoming more and more significant. Well, to come back to this issue of exaggeration, it is very easy, of course, to be seduced by what we see down a microscope. Here's some lovely work by one of my closest colleagues using the sort of cells that we generate in my lab, human embryonic stem cells. Michael Schneider has doped these cells, and here you watch a human heart cell made from a human embryonic cell, and of course it's beating. It's very difficult to look at that and not to be completely overwhelmed by the extraordinary ability to manipulate cells, given that, 40% of you in this audience will develop and die from heart disease. The notion that we might replace damaged areas of heart muscle with this kind of technology in 20 years' time, providing we get the immunology right, is something, and I don't think it's impossible. I think it's something which is really extraordinary. It's inevitable that we will start to feel huge certainty about what we do. Another problem, of course, about our science is that we live in a society which is mathematically illiterate far too often. And that's one of the reasons why, I've lost the battery to this thing. There isn't a battery. It doesn't need one. It flashes anyway. I've seen, look, there's an empty hole. It shows modern technology. And it's why centres like this are so extraordinarily valuable, looking at different ways. For example, you have an exhibition at the moment looking at maths and coral reefs, which is rather beautiful. This is an alarming headline from the London Independent, not the Irish Independent. 2.5 million men in Britain are infertile, which sounds interesting until you look at the figures. That means, let's say there are 58 million people in the UK. Let's say half of them are male, not unreasonable. That's 29 million. Let's say 10 million are still not trying to have a baby because they're too young. Even allowing for teenage pregnancy, I think 10 million is a fair and reasonable estimate. Another 10 million will be over my age, certainly not looking for a baby. That leaves 10 million men at risk. let's say half of them have got female partners or are married, and let's say half of them are trying at the moment. That means, of course, every single British man is infertile. And it's only when we start to really think about the ways that newspapers use statistics, that we realize that we have an important job to do in how we try to promulgate what we see as rational. We spread certainty with our pronouncements in the press. It's all very well to say that science is black and white, is the truth, as some of my colleagues argue. So that when you get this headline in the Daily Mail, you have, it's obvious to anybody on the top of the Clapham omnibus that there's an obvious difference between a cancer smear from the cervix, which is normal, compared with a normal smear from the cervix. And it's obvious that any fool doesn't need to be a cytologist to see the difference. The complete misunderstanding of the science. And I suppose this is really my argument with my genuine friend, who I like and admire immensely, Richard Dawkins. I think his certainty about science being the truth is seriously damaging to us as scientists. It doesn't matter whether or not you are an atheist. I don't really care about that at all. I think it's a perfectly tenable position to be either religious or atheist. I don't think it matters. But I think to argue that you're deluded if you don't believe what he believes is very, very dangerous. And it's interesting, here he is in front of a London bus. There's probably no God, so stop worrying, with Polly Toynbee and this rather beautiful, I don't know whether she's one of his PhD students from Oxford, I doubt it somehow. But whatever. Sorry?
Just because she's beautiful, that's why you tell.
But I mean, the science is wrong. I mean, the science is wrong because actually all the evidence tends to suggest that if you believe in God, you're less likely to worry. So, he's got even that bit wrong. And the problem there is there becomes a very narrow margin. This risks a serious polarization. This may be funny. This, I suspect, you would not find quite so funny. And this, I think, you would find is definitely inflammatory. So the issue then becomes, how our science is perceived, and the risk of dividing communities, of separating two cultures in the way that we do, it becomes much greater. Let me just turn to oil very briefly. Oil has been one of the most massively destructive technologies that humans have managed to cover. From this single gusher in East Texas in the early 1900s to this was a matter of 2 years. From $5 a barrel to 2 cents a barrel meant that actually by the time this happened in East Texas, it was 2 cents for a barrel of oil, but at least $1 for a barrel of water. And of course, the booming motor car industry was one of the key issues which ensured our dependence on oil. This lovely letter from villagers in central England in 1911 to King Edward says you must understand how much our children suffer from motor traffic going through the village. Here is Edward as Prince of Wales in his Daimler car in about 1903, I think. Sadly, the letter didn't seem to have much effect because in 1911 he bought this Daimler, which is something like, I think it's something like a massive engine, 9-litre engine, and really quite quick. It's now in a museum in California and used about 5 gallons a mile. The consequences of the oil industry have been devastating from time to time. And it was only perhaps just before the war when we started to realize the risk of fire, the risk of this school which was completely destroyed by an explosion on top of an oil area in Rusk County, which is one of the largest deposits in the world. It's still there and still producing oil. Was an example of the dangers. And of course, perhaps this might interest you to consider Fallujah. Fallujah is a town which has suffered over a century from repeated incursions. Our record in Iraq and Iran is not great. And essentially, the wars in Iran and Iraq have been really about that one commodity. Certainly, I think Fallujah has been very important in that issue with oil. It was once a booming cultural community back in the times of in the early parts of the first millennium. Finally, let me talk about one other technology to make my point about this unforeseen consequences. It's almost exactly 50 years since the laser was invented. In fact, I think the patent was exactly 50 years ago. And when the laser was first explored, if you look at the patent, it's obvious that nobody considered for a moment there might be a way of getting rapid data transfer with a laser, or indeed this pointer, that we would refine surgery, particularly eye surgery, that we would make a CD machine, or have barcode reading, or of course make gene sequences which depend on the laser, and make accurate measurement in a domestic environment, or build dual photon or other types of microscope. And once we get lasers down to the nano level, and that looks like being increasingly possible. I think most physicists regard that only as a matter of time. To give you an idea, a nanometer is 1/1000th of a meter. That's correct, isn't it? The smallest living organism would be mycoplasma, which is about 2,000 nanometers across, so you get some idea of scale. A human hair would be about 25,000 nanometers across. Once you get down to the nanometer level, you have the possibility of visualization of atoms. You could actually look at the structure of DNA individually and see individual base pairs, because it's about 2 nanometers across the double helix of DNA. You can do quantum computing, interplanetary signaling, and of course, nuclear fusion becomes a possibility, saving the planet. I've just recently come back from California. I was in Livermore just a few weeks ago, and here is this extraordinary machine which occupies the size of about 3 football pitches. No, more than that really, about 2 Wembleys. It's massive, 2.5 Wembleys. It's a huge, huge investment by the United States government, costing about $116 million to run. And in this chamber here, which is surrounded by 2 foot of concrete, it's 5 meters high, this spherical, and outside us is another sphere of concrete, which is about 8 foot of concrete. Into this machine are focused 192 of the world's most powerful lasers. And each of these lasers is focused on a capsule, which is like this size only, and inside that capsule is a pellet of frozen deuterium oxide, which is just 2 millimeters across. And each of those lasers is focused on that pellet from all round the chamber. Here you see the machine by which it's brought in, at the tip there, and here are the lasers coming through these very portholes. You get an idea of the scale with these men in the crane. What's interesting, of course, is that at the moment when the lasers are switched on, the power delivered to that 2 millimeter area is more power than that generated by the entire United States national grid. It's immense. And what happens, of course, is that that pellet becomes crushed, compressed, and protons fuse. And at that moment, of course, more energy comes out than is put in. Nuclear fusion is certainly a possibility for the future, and this may be one of 2 key ways of getting it working. Ed Moses, who directs that unit at Livermore, is extraordinarily bullish about it, and certainly the press comments coming out of Livermore are entirely enthusiastic. In his view, it's only next year that they'll generate enough neutrons to heat water with a turbine. Well, we'll wait and see. I asked Ed how it was he managed to persuade George W. Bush, the previous administration, to give him $116 million a year. Oh, he said it's quite simple, he said. Of course, it's part of our nuclear weapons program. the ultimate downside of the technology. So it's very interesting, this kind of harmonization between two areas of research. Would we stop that work? No, of course we wouldn't. Can we control that technology? No, probably we can't control the science, nor should we try to do so. But we may need to find a new compact with society. And in my view, that's what we have to do as scientists. That's why an installation like this in the heart of Dublin is such a magnificent thing to be doing, because the need for better science literacy is a key. And in my view, I think there are two things that we need to be doing in our society. One is that we as scientists need to recognize that we need to be much more modest about what we're doing, to recognize the limitations of what we are, to recognize that there is no such thing as truth, that there are gradations of truth, to recognize that actually we need to find ways of, which you're doing beautifully here, of communicating more effectively with people who are not scientists, and actually to recognize also the ethical limits of what we're doing, and recognize the limitation of commercial involvement. Regrettably, both in Ireland and in the UK, so much science is now stimulated by the thought that economic growth is dependent on scientific endeavour. What I've talked about here, for example, the laser, it would apply to the microchip, it would apply to the MRI machine, it would apply to the contraceptive pill, it would apply to the internet, it would apply to Big Bang, some of the 10 greatest inventions of the last 50 years. None of those inventions were goal-orientated. Nobody set out to design a laser. Nobody set out to design a microchip which would actually change the way we communicate, or the internet and so on, in the way that we do now. And so we have to recognize that actually it's basic, non-goal-oriented science which is important. So with those things in mind, I put up 7 aphorisms about science. I could put up more, which I describe in this book. I want to point out that most of the discoveries that are heralded by our society are usually exaggerated in their importance for their imminent value, and that nearly all of them have a threatening aspect that we don't recognize. That most discoveries have a beneficial application which aren't recognized when the discovery is first made, and that democratic governments even misuse knowledge. Now, the reason why that's so important, of course, is that that use has to be recognized. So the science that you and I do as scientists, those of you that are scientists in the audience, have to recognize that, I think we have to recognize, that it's not our science. The science that I've done has been paid for by the taxpayer, that is, by the general public. And without that support, that science couldn't have been done, and therefore that science not only belongs to the society in which I live, but its negative effects will have consequences for that society in which I live, as well as the positive ones. And we have to recognize that sense of responsibility. I think we also have to recognize that we constantly reinvent the same technological advances and rediscover the same discoveries again and again. I know that's certainly true in my own career. I'm in some 300 peer-reviewed publications. I don't know that I've got a single one that's truly original. At the time, they seemed very exciting. When I look back, I recognize that so much is built on other people, or one forgot about other people. And above all, we need to recognize that we can't predict the future, and we're not always objective. We're human like everybody else. Now, the converse of this is that there's also a responsibility of society. It can't be just left to scientists. In my view, there has to be a recognition that in a healthy society in future, there has to be better science education. Because if we don't have a science literate community, then of course, no matter how much we may want to be altruistic in what we're doing, no matter how much we try to engage the public, if we don't win the battle to get better science education seen as important as Yeats or Shakespeare or any other aspect of our culture, then I think we are doomed. I don't believe we're doomed. I think all the problems that we see from global warming downwards are capable of being tackled effectively, but only if we have that kind of contract with the society in which we live, something which was not shared perhaps by Joseph Wright of Derby in this painting shortly after Priestley showed the lack of air, in fact oxygen of course, in this glass vessel would kill the gull which is trapped in it. And what's interesting, I think, to me about this painting, which is in the National Gallery, gosh, it's a long time since I've seen it, so forgive me while I stare at it, is that here is one scientist philosopher who's staring into the distance, really quite concerned about what's going on. These two children, one's a teenager presumably, are too frightened and worried about the fate of the bird even to look at the experiment, even though somebody's trying to explain it to them. The little boy is trying to shine light from the moon on the room, and these two are busy with the usual sorts of things that sex produces. But notice the face of the scientist. The scientist is not communicating with anybody in the room. He's actually in a world of his own. That should not be a message for us, ladies and gentlemen. Thank you for listening.
I was just wondering if perhaps I could kick off. How do you think science education in schools needs to change?
Okay, good question. Two key ways. First of all, we know from a great deal of experience now and various research that's been done that the one thing that turns children on of all ages onto science is getting their hands wet, doing practical experimental work. So there needs to be a huge improvement in the quality of science experimentation, doing dissection, doing what seem to be dangerous experiments, which health and safety don't like very much, getting children involved with experiments, which I think many of you who did science in school will find that the most intriguing thing that you did. That seems to be clear. In England, we know from a recent survey done in the House of Lords that at least 30% of schools have laboratories which are so inadequate, experiments are hardly done there at all. And that is quite a shocking indictment of our society. The second issue is having inspirational teaching. It's something that you mentioned. And for many of us, that's what turned us on to science. I think that there's a real need for doing that. You know, if you look at A-level courses in physics in Britain, the shocking statistic is that only 30% of physics teachers at A-level did physics as their first degree at university. Now, of course, you can teach physics as a chemist. It's not impossible. But you can't get the inspiring aspect of physics in there because it's not part of your philosophy. At least it's much more difficult anyway. And we don't allow proper career professional development. So one of the things that I'm really struggling with my role at Imperial College is to try and find ways that we might improve that, what sort of initiatives we could do to do that.
Great, thank you very much. Any questions? Yes, over here.
I'm just wondering if it's one thing having a newspaper printing or giving a misleading take on something scientific. When you have a journal like Science, which is peer-reviewed and highly, highly respected, publishing something which you gave as one of your examples that you thought was, I think you said, genetic nonsense. Do you think there's a problem with the peer review system as it stands?
Well, that was an editorial, so it didn't go through the usual peer review. I mean, Science does peer review its editorials, but I know from my own experience, certainly the stuff that I've written, not very often, admittedly, I wish I'd done more, but you know, it was only a limit to how often they'll ask you. It's not peer review with great rigour. But you're right, the peer review system in science and nature is not by any means perfect. It's worth bearing in mind, you remember that classic example of the Korean paper, the famous Korean paper, which announced cloning cells for transplantation, which of course made the press in every country in the world, which clearly was fraudulent. And actually, when you read the paper at the time, and I remember reading that paper thinking, I don't understand the statistics of how they did that. And I was being phoned by journalists asking to comment, you know, somebody working in a stem cell lab, saying, well, actually, I need to reread that paper. And I didn't talk about it. It was only months later that I realized that actually, in fact, clearly it wasn't peer-reviewed by people who were doing stem cell embryology. They were doing the immunological side. And so they didn't understand the limitations of the embryonic cells. And that was that aspect that puzzled me at the time. And I think a lot of people felt the same way, but they felt nervous about speaking out. And I think peer review in general journals is quite a difficult issue anyway. Nature and Science are quite unusual in that respect, because they're journals which publish science that they regard as being of general interest. And of course, as science becomes more complicated and more rigor is required to look at some of that general interest, it becomes quite difficult. And I think it's inevitable that mistakes will be made. So one can blame the journals a bit. I mean, you could argue that Andrew Wakefield is much more significant. The Lancet should never have published those papers. And it was quite scandalous that they did, and then tried to support their publication afterwards. That was more than just a failure of peer review. That was a failure of editorialship, I think.
I completely agree with what you're saying about needing to get back to the source with our children and educating them, improving the standard of science uptake in physics, for example. But as you mentioned yourself, the societal danger of having if you like, Andrew Wakefield's coming out with poor, bad science, or, as Ben Goldacre said in his recent book, Bad Science, the threat of bad journalism is really, really very, very dangerous. Do we need something? Do we need a like a government science guru or PR or whatever? Do we need 100 Brian Coxes out there or another 100 Robert Winstons out there? How do we deal with that?
Well, I don't think Brian Coxes and Robert Winstons are the answer, really. Though it's very flattering for you to suggest it. Well, maybe it's cloning both of us. Sorry. Not a good idea, actually. A very bad idea. No, I think it's a recognition of what we've never done as scientists is to meet the editors. We meet the science journalists, and the level of science journalism is pretty high in Britain, actually. I mean, there have been a succession of really good science journalists, and increasingly in the last 2 or 3 years, there's been a significant improvement, I think, in science reporting, probably started by Roger Highfield at the Telegraph, who kind of led the way. But people like Robin McKee, for example, at the Observer, and many others have been exemplary in how they report science. The problem, of course, is that doesn't sell newspapers. It's that headline that sells newspapers. So it's how you get to Paul Dacre is the trick. And I don't know how we do that. I don't think you can regulate in any way. But I do perceive an increasing recognition from the more serious press that they have to be much more reflective about what they're reporting. I think, to give one example, and I'm a bit embarrassed to say this because it sounds rather critical, but I think when Mark Henderson started at the Times, he was not a particularly good science journalist. I mean, I think that he went for sensational, quick-fix stories. Seeing the stuff that he writes now, there's no doubt there's much greater maturity about what he's writing. And I think that there has been a change in good science journalism. And that gets respected by editors. I mean, the fact is he still gets quite a big area of the Times where he reports. And, quite a lot of newspapers now have science supplements. So, yeah, of course, it's nice to have lots of people like Jim Al-Khalili and Alice Roberts and Kathy Sykes and Brian Cox on telly. But I don't think that really is the answer. I think actually we have to have a better relationship with the press than we have. We've tended just not to have that relationship, and I think it's been deleterious.
So it's funny, someone was saying to me that it's strange that, you have food critics, you have art critics, but you don't really have science critics. And, one thing in science journalism in Ireland, often you get sort of quite a simplistic sort of a celebratory representation of scientific discoveries, but a sort of thoughtful, reflective criticism. Not the kind of scare headlines that you were talking about, but a sort of thoughtful critical writing about science is quite rare in the press here. I think it's fair to say. In the UK it's more common.
My impression of the Irish press is that it's not quite as good in this respect as the British press. On the other hand, it's also very clear that
disagree. Maybe there's some journalists here who disagree.
I mean, it's fine if they disagree. I'm very happy to argue it. And, I don't perhaps read enough of the Irish press, but it's also very obvious from the attention that's given by the Irish press to the clear interest in science there is in this country, which is massive. Now, I think that's been increasingly literate over the last 10 years. It's very obvious, big difference. I think, it's very nice to be able to congratulate you on this place, but it's an example of, what we should be doing in universities more and more. And I think, for too long, universities have been tended, not Trinity College, not so much, but many universities in England, quite cut off, quite elitist institutions, which you're frightened to walk into. People do not go into Cambridge colleges. Indeed, there's usually a notice saying the college is closed, until 4 o'clock, or between 4 and 5 it's open briefly, and you can only go into this quadrangle, but not that one. I mean, that is no longer an acceptable attitude in a university. Our universities should be seen much more as part of the community, which is partly responsible for them, and which they should be supporting.
Thank you. Up here, this question.
Thank you very much for your very interesting talk. I look forward to reading your book. If you've done a comprehensive analysis of the threats posed by science and technology, I'm wondering, or I'd be interested to know if you have identified what you might say is the single biggest threat that you perhaps discovered.
I've been asked that question before, and I don't know. The one that's, of course, obviously in our mind is the issue of climate change. But I think there are so many different threats. I mean, some of them are not at all obvious, and of course, they also require a degree of prediction, which, we're hopeless at anyway. In fact, scientists should never be predicting anything, because they probably less... You remember Lord Kelvin, who, 3 years before the Orville Wright famous start, said, you can take it from me that heavier than air flight is impossible. He also said X-rays didn't exist too, didn't he? I mean, we get it wrong. One of the interesting things is Tim Berners-Lee's great invention, the internet, which of course is one of the most democratizing influences in our society. It enables the free transfer of information to people who are not necessarily formally educated in a way that was never possible before. It's truly democratic. It's the end point of writing. And yet, of course, it's also one of the biggest threats to our democracy, because on the internet you can spread sedition, you can spread libel, you can spread hate, you can spread violence, you can spread pornography, and it may be possible to collapse the internet, in which case you'd suddenly find a closure of the world's banking systems, much of our commerce, and a whole range of things which will be thrown into total chaos for a while, with massive consequences, and could actually be quite destabilizing to many countries. So I think it's very difficult to really answer your question in a sensible way, but clearly one of the big threats, I think, is the failure that we haven't succeeded really, I think, in having properly educated debates about climate change and its effects. And that, I think, should worry us. The skeptics grasp at the straw of, East Anglia University. The Royal Society grasps at the certainty of every publication showing that we're heading for disaster. And neither scenarios seem to me to be entirely palatable.
I think we have time for just one more question, and then...
Sorry, I've talked too much.
Then we might have the books. Do we have the books? Is it right? Okay. One more question? Do we have one more question? Yes.
Just a quick one. I know you said that you don't believe that scientists can predict the future, but I'm wondering what kinds of new technologies or perhaps applications of technologies or demos have you seen recently that have really sort of excited you and blown your socks off? You could just maybe comment on that.
I'm not sure I understood the question. What sorts of...
new technologies that have blown your socks off? And
what's really impressed you or excited you? Or
Well, I think one of the most... one of the things that I'm particularly... I'm a member of the Engineering and Physical Sciences Research Council, so we're very heavily involved. Although I'm actually not a physical scientist, I'm a biologist really by training. I've sort of become a kind of physical scientist by default. I mean, a very poor one, I have to say. So I've got very interested in things like nanotechnology and synthetic biology. I'm very unconvinced about synthetic biology, I have to say. I'm very convinced about nanotechnology, and the thing that convinces me most about nanotechnology is the complete uncertainty about that technology. It's extraordinary to me how something in one particular configuration can be completely harmless at 50 nanometers across, but might be highly toxic at 70 nanometers across if it's a cone rather than, let's say, a rod. So I think Richard Feynman's wonderful lecture, which I recommend everybody to read who's interested in public engagement, the 1960s, that famous lecture at Caltech University, is something that is worth looking at again. I know that we can't predict as scientists, but Richard Feynman came really close to getting something very close to the real intriguing aspects of science in that lecture. An extraordinary man, actually, and an extraordinary topic. Thank you.
Thank you very much. So, as we said, we have a few copies of Bad Ideas that Professor Winston is very kindly willing to sign. And we would like to take this opportunity to thank Professor Winston for this phenomenal, wide-ranging talk and this stimulating discussion. Certainly lots of food for thought for us here at the Science Gallery in terms of how we connect the public with science and how we sort of tread that fine line between sensationalism and science and between the new and exciting scientific developments and the hype that they can generate. So I'd like to ask you to join me in thanking Professor Robert Winston for this fabulous talk. Thanks.